Warning: this video was created for educational purpose. The main goal is to provide scientific and public health related information in an understandable, easily digestible manner, with a portion of humor. Might contain disturbing disease-related images and information. What are parasites? Let's refer to the History of Human Parasitic Diseases by Francis Cox, 2004, Infectious Disease Clinics of North America. Strictly speaking, any infectious agent can be described as a parasite, but the term is usually restricted to the protozoa and helminth worms. Let me elaborate on this. Protozoa are single-celled, eukaryotic microorganisms, either free-living or mostly parasitic. Helminth worms, alternatively called parasitic worms, as the name itself says, are parasites infecting the digestional tract of humans and other animals. These are highly evolved and opportunistic organisms that can be found as parasites in all classes of the animal kingdom. It is not surprising that humans should harbor some parasites, but what is remarkable is the number of different species that can infect us. Nearly 300 helminth worms and about 100 protozoa. Not all of these are pathogens, but some are responsible for about 20 human diseases or disease complexes. And these are among the most important diseases in the world, mainly in the tropics. And the guest of our today's program will be Plasmodium.
So please welcome
Plasmodium unicellular protozoan parasites belonging to the genus Plasmodium are the causative agents of malaria. These parasites infect not only humans but also other vertebrates, from reptiles and birds to mammals. To date, over 200 species of Plasmodium have been formally described, and each species infects a certain range of hosts. Plasmodium species that naturally infect humans and cause malaria in large areas of the world are limited to 5: Plasmodium falciparum, Plasmodium vivax, Plasmodium malariae, Plasmodium ovale, and Plasmodium knowlesi. The first 4 are specific for humans, while Plasmodium knowlesi is naturally maintained in macaque monkeys and causes zoonotic malaria widely in Southeast Asia. Let me elaborate on this. Zoonotic malaria means the transmission of the disease is happening cross-species, in this case the macaque monkeys versus humans, and as we see later in this description, it happens by a vector, in this case a mosquito. Transmission of Plasmodium species between vertebrate hosts depends on an insect vector, which is usually the mosquito. The vector is not just a carrier but the definitive host, where sexual reproduction of Plasmodium species occurs and the parasite's development in the insect is essential for transmission to the next vertebrate host. The range of insect species that can support the critical development of Plasmodium depends on the individual parasite species, but all 5 Plasmodium species causing malaria in humans are transmitted exclusively by Anopheline mosquitoes. Plasmodium species have remarkable genetic flexibility, which lets them adapt to alterations in the environment, giving them the potential to quickly develop resistance to therapeutic such as antimalarials and to change host specificity. And now let's have a closer look on malarial life cycle of Plasmodium. First of all, we have an infected mosquito biting a person during its blood meal. Being bitten by an infected mosquito, a person becomes infected with a certain developmental stage of Plasmodium, the so-called sporozoites. The sporozoites then enter the liver cells, in which they undergo a series of developmental stages, which leads to a 1,000 and 1,000-fold replication of the parasite. The parasite exits the liver cells, re-enters the red blood cells, and undergoes another series of developmental stages in the red blood cells. And there we have it, the final stage, the gametocytes. The vicious cycle closes as another mosquito lands on the skin surface of a malaria-sick individual. The mosquito takes a blood meal, thereby ingesting infected red blood cells. The parasite exits ingested red blood cells, infecting the mosquito, and undergoes another series of developmental stages. Finally, we have a mosquito carrying the parasite in its saliva. And there we have it. A life-threatening organism has just been generated. According to CDC, Centers for Disease Control and Prevention, globally, the World Health Organization estimates that in 2020, 241 million clinical cases of malaria occurred, and 627,000 people died of malaria, most of them children in Africa. Because malaria causes so much illness and death, the disease is a great drain on many national economies. Since many countries with malaria are already among the poorer nations, the disease maintains a vicious cycle of disease and poverty. When looking at the distribution map of malaria, we see that it's mostly the southern and central African countries being affected, Southern American countries, Southeast Asia. What are the signs and symptoms of malaria? Symptoms of malaria include fever and flu-like illness, including shaking chills, headache, muscle aches, and tiredness. Nausea, vomiting, and diarrhea may also occur. Malaria may cause anemia and jaundice, which is the yellow coloring of the skin and eyes, because of the loss of red blood cells. If not promptly treated, the infection can become severe and may cause kidney failure, seizures, mental confusion, coma, and death. If you are experiencing any of these symptoms,
You're screwed.
don't hesitate to contact your healthcare provider. The surest way for you to know whether you have malaria is to have a diagnostic test where a drop of your blood is examined under the microscope, the so-called blood smear examination. The examination just monitors whether the malaria parasite is present in your red blood cells. If you are sick and there is any suspicion of malaria, the test should be performed without delay. And last but not least, an interesting fact to finish up. The strong negative pressure of the disease has likely forced the evolution of human populations in malaria endemic regions and the selection of some unique genetic variants. For example, thalassemia and sickle cell disease, each of which is a genetic disorder affecting the red blood cells, are commonly found in malaria endemic areas. And people with these two disorders show resistance to malaria. If you enjoyed this video, just hit the like button, click subscribe and activate the notification bell, because this helps me improve the quality of the content in the future.